What happened? Am I audible?
Yes, ma'am, you're audible.
Okay, ma'am. How was your exam? Did your exams well? Okay, fine. Hope.
Yes, ma'am, it was fine.
Good. Okay. Hope all well and your exam is well. Okay, now we are going to proceed with till this point what we have discussed. We have discussed what is the expression, what is regular expression, and then what we have discussed the automata, finite automata. What is the use of finite automata? The finite automata will accept the regular languages, right? It will accept the regular languages. And then in the automata, we have discussed different things. One is the two types of automata we have seen, finite automata we have seen. One is deterministic finite automata, and the next is non-deterministic finite automata. And so already we have discussed both are of equal strength, right? So what we did for that, in order to prove it is of equal strength, we have converted the DFA to NFA and NFA to DFA. Yes, right. Okay. The next we are going to deal is regular expression and finite automata or equivalent strength. Already we have also proceeded with that. How to prove that? So please make a note, the regular expression and automata are of equivalent strength. So in the sense, again, what we have to do, we should be in a position to convert finite automata to regular expression and regular expression to finite automata. Already we have discussed one thing for that, that is NFA, regular expression, NFA from that is regular expression to NFA we have discussed, right? McNaughton Thomson algorithm, right? McNaughton algorithm we have discussed for conversion of regular expression to NFA, and also we have discussed how to convert the finite automata to regular expression also. We have discussed that also. Now we are going to continue with the construction of DFA from a regular expression. So till this point we have discussed construction of NFA from a regular expression by means of McNaughton-Thomson algorithm. Now what we are going to do is we are going to proceed with construction of DFA from a regular expression. Okay, DFA from a regular expression. So this is called as an optimization technique. So minimization of DFA we have discussed. I hope you can recollect it, right? So minimization we have discussed, right? So that is one of the optimization technique. And similarly, construction of DFA from regular expression is also one of the optimization of DFA. So optimization in the sense number of states in the DFA will be minimal. Okay, number of unwanted transitions will not be there. So when we are proceeding with converting from NFA to DFA, there is a possibility of having some unwanted states. So for that we discuss the minimization of DFA, which is one of the optimization technique. Right. So here we are going to construct DFA directly from a regular expression. This is called as a direct method. Okay, here in this case, if you are going for a direct method, then your DFA will be an optimized DFA. There will be no need for minimization at all. Okay, you will get a minimized DFA. Right. Okay, so here we can start with one example how we are going to proceed with converting the DFA from regular expression. So in order to proceed with directly constructing the DFA from a regular expression, we have to identify the important states in the NFA. Okay, we have to identify the important states in the NFA. Important states in the NFA. This is the NFA. So here we are going to proceed with constructing the DFA for the regular expression. Already we have discussed this regular expression for regular expression to NFA, right? So here we are taking the same regular expression for conversion to DFA as well. Okay, so here for this regular expression only, we are going to proceed with constructing the DFA. How we are going to construct the DFA? So in order to deal with that, to direct construction of DFA, we have to first identify the important states of NFA. So what do you mean by the important states of NFA? The NFA states with non-epsilon out transitions. Please make a note over here. Here we are not going to construct NFA at all, okay, but how we can identify the important states of NFA. So the direct construction of DFA is going to be dependent upon the important states of the NFA. So what we mean by the important states of NFA? So it is nothing but the NFA with the non-epsilon out transitions are called or considered important. Here you can see 2 is having non-epsilon out transition, right? And 4 is having non-epsilon out transition. 7 is having non-epsilon out transition. 8 is having non-epsilon out transition. 9 is having non-epsilon out transitions, right? So, except the start state, okay? So, here all these states are having non-epsilon out transitions, okay? Non-epsilon out transitions. So, these states are the important states. So here you can see this final state is also much important, right? This final state is so much important. But if we are considering a category of non-epsilon out transition, non-epsilon out transition, then this final state is not having any non-epsilon out transitions, right? So here 10 will not be considered. Though it is a final state is an important state. So though it is an important state, it is not meeting this criteria, right? So we have to make it as an important state. Okay, so for making this as an important state, it should have a non-epsilon out transition. So for that, what we will do is we will be converting this regular expression to a augmented regular expression. Augmented in the sense we are going to add something to a regular expression, right? So what we are going to add? Just we are going to proceed with adding a hash at the end. If I am adding a hash at the end, what happens? So this will be becoming the intermediate state, and then on hash moving on to the another state, right? So now 10 will become an important state, right? Now 10 will become an important state. Okay. So non-epsilon out transition. So here we can proceed with, in order to proceed, yes. So here the first step in direct construction of DFA is nothing but first we have to convert this regular expression to augmented regular expression. So that is we have to add an hash, concatenated an hash at the end of the regular expression. Okay. So this is the first step. Okay. So convert regular expression to augmented regular expression. So this is the first step. Okay. So what happens? So we'll be having a regular expression like this. Okay, we'll be having the regular expression like this. So now next step is to construct the parse tree. Okay, so here we are going to construct the parse tree. While constructing the parse tree, we are going to use, as usual, we are going to use the operator precedence of operators. Okay, so first this within the brackets needs to be evaluated. Okay, A, B. So here brackets A, R, B, the whole star. So meaning it is going to be yes, right? We are not going to include brackets over here. Only based upon the precedence, I am going to construct parse tree, and then A, R, B star is A, R, B is going to be given with the clean closure. Okay, clean closure. So please make a note over here. A, R, B star, right? So for A, R, B, I have constructed a parse tree. For that parse tree, I have given the clean closure. And next comes, I am going to concatenate it with A. So here for concatenation, we'll be using a node called as cat node. We'll be using a node which is represented by this. Okay. For concatenation, we'll be representing node like this. Okay. Okay, here please make a note over here. Here in this parse tree we'll be having only OR operator, star operator, and the concatenation operator. Only these three operators will be present in the parse tree. Okay, so A or B star is over, and then this needs to be concatenated with A. So I have to proceed with concatenation with A. Okay, so this is over, and again concatenation with B, and then concatenation with B, and then concatenation with ash. Are you clear with this?
Yes, ma'am.
Yes, good. Okay, right. Now the next step what we are going to do is, we are going to number all the leaf nodes, non-epsilon leaf nodes. Some of the nodes may have epsilon, right? Some may have epsilon. So here in this case, none of the leaf nodes are having epsilon. Okay. So the next step is non-epsilon leaf nodes should be numbered. Okay, so here all the leaf nodes is going to be numbered here. So this leaf node is numbered as 1, and this is next leaf node, and this is next leaf node, and here 4, 5, 6. Okay, so please make a note. First step is converting the regular expression to augmented regular expression. So how we are going to proceed with the augmentation? Just adding an hash at the end. Next step is proceeding with constructing the parse tree. Okay, while constructing the parse tree, we will be considering only the OR operator, link closure, and then concatenation. Brackets we will not include over here. And the next step is going to number all the non-epsilon leaf nodes. Okay, all epsilon leaf nodes should be numbered. Okay, so the next what we are going to do is we are going to deal with some set of functions. So here we are going to deal with the 4 functions. We are going to just work on with this parse tree only now. Okay, here we will be dealing with 4 functions. So first is going to be nullable. Next comes the first position, last position, and follow position. Okay, we are going to work on with 4 functions. First is nullable, first position, last position, and follow position. The first step is to proceed with finding the nullable of each and every node. Okay, each and every node in the parse tree. We are going to find the nullable of each and every node in the parse tree, whether it is leaf node or the intermediate node. We are going to find the nullable. How to find the nullable? The nullable is true. So nullable in the sense we are going to check whether it is null or not. Null in the sense empty or not. If it is empty, this function will return true. If it is non-empty, the function will return false. Okay. Here it will return true only if it is having epsilon. So okay, let us start with this. So please have a look at it. Right. So please do. Let me share this in the chat box as well. Hope you will be writing it in your notes, right? So please do note this down because we cannot refer periodically. So please do. I am sharing it in this chat box, so you can write it in your notebook. Okay. So here first we are going to deal with the nullable. Okay. So what is nullable? So here nullable is nothing but okay. So what is nullable? A leaf labeled epsilon will have nullable as for a leaf node, if it is going to be epsilon, if the leaf node is epsilon, then for that we will the nullable function will return true. If the leaf node is having a position I in the sense it is going to be the number given. Already we have numbered each and every non-epsilon leaf nodes. So if it is having a position I, that is I in the sense it is non-epsilon node will be having the position number, right? So in that case, the nullable will return false. So next we have discussed with regard to leaf nodes. If it is epsilon, then true. If it is some other input alphabet, then it will return false. Okay. Then comes the intermediate nodes where we will come across the operators, that is OR, CAT and star. So for the OR node, so what is R node? R node is nothing but C1 or C2. Okay, C1 or C2. So when it will, so what about nullable for R node? It is nothing but nullable of C1 or nullable of C2. If either one is true, then it will be true. Okay, if nullable of C1 is true, then it will be true. If nullable of C2 is true, it will be true. Either of one is true, then it will be true. Okay, then next comes the cat node. So here nullable of C1 and nullable of C2. If only if both are true, this function will return true for the cat node. And star node, yes, star, you all aware that it will have epsilon, right? So it will have epsilon 0 or more is nothing but clean closure. Is true. Okay, let me repeat. For leaf node, if it is epsilon, then it is going to be true. If it is going to have the valid input alphabet, then it is false. For OR node, it is nothing but nullable of C1 or nullable of C2. For cap node, it is nullable of C1 and nullable of C2. For star node, it is nothing but true because it will have epsilon, right? Okay, now we can deal with an example here. Okay. Yes. Okay.
Excuse me, ma'am.
Yes, ma'am.
Ma'am, there's a lot of background noise in the behind, so it's very difficult to understand what you're saying sometimes.
Nobody is here, ma'am.
Ma'am, there's a lot of background noise. There's like a lot of noise in the background. Yeah, now it's better.
Now it's better. Nothing I have made,
Yeah,
ma'am.
because no, ma'am, because sometimes it's become very difficult to understand what you're saying.
Probably due to network issues, I hope, because no one is here.
Ma'am, sound is coming from mic. It's not a network problem. Mic.
Mic.
Yeah, ma'am.
Okay, let me remove my mic first. How about now?
It's less, ma'am.
It's better.
Yes, ma'am.
Yes,
Okay,
ma'am.
fine. Okay, sorry. Okay, let me proceed. Right. Yes, what we are going to do. So now we are going to deal with nullable, right? So here this is the leaf node. So here the leaf node is a valid alphabet. So whether is it true or false?
False.
False. False. Is my voice clear now? You feel comfortable, right?
Yes, ma'am. Yes, ma'am.
Okay, good. Okay, the next comes. Are you clear with this? Yes. So next comes the OR node. So what we saw for the OR node is nothing but nullable of C1 or nullable of C2. This is C1 and this is C2. So what is, so here both are false. So what happens? It will be false here. Yes, good. Next comes star clean closure. So for clean closure, what we saw? I think you can refer I have shared it in the chat box, right? You can refer that. So asterisk is for a clean closure. Yes, it is true. So because it includes epsilon 0 or more, right? So it is true. And next comes cap node. So this is C1 and this is C2. Okay. What is for cap node? Nullable of C1 and nullable of C2. Here false. Yes. So here false. 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 Are you clear with this? Shall we proceed?
Yes.
Yes. Next comes the first position and the last position. It is again a very simple one. So it is going to be first position of the particular node. Okay. So what about first position of epsilon? That is, if the leaf node is empty, the first position is going to be empty, right? It is going to be null. Okay. So if the leaf position is going to be a valid input alphabet, then the first position is going to be that specific position itself. Okay, so leaf position is I. If position is I, then first position of that node will be I. Okay, and then for our node, it is going to be first position of C1 union first position of C2, and only a little bit complexity is there for the cat node. So just you please make a note over here. So for cat node, we will check whether nullable of C1 is true. Okay, we will be checking whether nullable of C1 is true. If it is true, we will be taking union of first position of C1 and first position of C2. If not, it will be first position of C1 alone. Okay, so please make a note over here. So for R node, it is going to be a straightforward thing. Just we'll be taking union of both. If it is going to be cat node, then it is going to be, we'll be checking whether nullable of C1 is true. If true, we'll be considering this condition. If false, we'll be moving on to this condition. For star node, it is just again straightforward. It is going to be first position of C1. Okay, so here, yes, we can start with. Okay, so we can start with here. Yes, first we can mark the first position of all the leaf nodes. Okay, okay, so what about the first position of this node? This is nothing but 1. Here,
Yes.
2, 3, right? And next we can move on to the intermediate nodes. So that is R node. So for R node, what we saw, first position of C1 union first position of C2. So what will be the thing? 1, 2, right? And next comes the star node. So for star node, it is nothing but first position of C1. So this is C1. Okay, good. 1, 2. For cat node, so for cat node, we discussed with regard one condition, right? So if nullable of C1, okay, so we have to check whether nullable of C1 is true or not. So this is cat node. For this cat node, we are going to find the first position. So what I have to do, so with respect to this cat node, this is C1 and this is C2. Okay, so we have to check whether nullable of C1 is true. So in this case, it is true. So what should I do? I have to take union of first position of C1 and first position of C2. So it is going to be 1, 2, 3, right? And next comes this cat node. So what I have to do, I have to take first, I have to consider these two. Here you can see this is nullable of C1 is not true. This is false, right? So what should I do? I have to take only 1, 2, 3. Yes, good. So here again, this is C1, this is C2. Here nullable of C2 is false. So what should I do? 1, 2, 3. And here this is C1, this is C2, this is false. So what should I do? 1, 2, 3. Are you clear with this?
Yes.
What about others, ma'am?
Yes, ma'am.
Yes, good. Thank you. Okay, similarly, the last position is almost similar to the first position. The only change comes with the cap node. Okay, so here for last position is if it is epsilon null, if it is valid input alphabet, then the corresponding position will be the last position. And for R node, it is last position of C1 union last position of C2. For cat node, we'll be checking nullable of C2. Please make a note, here we'll be checking nullable of C1. Here in this case, we'll be checking nullable of C2. If true, then we'll be taking union of these two. Else, it is going to be last position of C2. Okay, please make a note. Please do compare here. Here we are checking nullable of C1. If true, we are taking the union. If not, we are taking first position of C1. Whereas here we are checking nullable of C2. If true, we are taking union. Else, we are proceeding with nullable of last position of C2. And yes, for star node, it's nothing but last position of C1. Okay. Okay. Now we are going to deal with the last position. First, we can complete the last position for the leaf nodes. Okay. 2. Right. Now we can move on to the intermediate nodes. Okay. For R node, what is last position of R node? It is nothing but last position of C1. Yes. Last position of C1 union last position of C2. It is nothing but 1, 2. And what about this star node? Is again it is last position of C1 1, 2. Here cat node, it is yes, what we have to do, we have to check nullable of C2. Nullable of C2. So here in this case it is false. So what should I do? I have to
last position of C2.
C2. Yes. Here again false. Nullable false. Sorry, last position of C2. Here again nullable of C2 is false. So I have to go for last position of C2. So here again nullable of C2 is false. I have to deal with it. Are you clear with this? Yes. Shall we proceed? Yes. Okay. Next comes the follow position. Okay. So here please make a note over here. Follow position. So for follow position, we'll be considering only the cat node and the star node. Okay, we'll be finding the follow position for all the numbered nodes. Right, please make a note. We'll be for that is only for the leaf nodes. Okay, only for the numbered leaf nodes we'll be finding the follow position. So how many numbered nodes are here? 1, 2, 3, 4, 5, 6 are the numbered nodes. So we'll be finding follow position of 1, follow position of 2, like that it goes on till follow position of 6. Not for the intermediate nodes we'll be finding the follow position. So please make a note over here. Nullable first position, last position will be computing for all the nodes in the tree, whereas the follow position will be only for the numbered leaf nodes. Okay, so here the numbered leaf nodes are from 1 to 6, so only for all the 6 positions we will be finding the follow. How to find the follow? So in order to find the follow, we will be dealing with the cat node and the star node. Okay, so for example, if I want to find the follow position of I, okay, so please make a note of this procedure, and then if we deal with the example, it will be clear for you. I am going to find the follow position of I. So for example, if I okay, I is going to be the number here. Okay, so what I will be doing, I'll be first I'll be checking the cat node. Okay, the cat node, if I is present, I'll be checking whether I is present in last position of C1. Okay, in cat you are aware that it will be having C1 and C2, right? So what I will do is I'll be checking whether I is present in last position of C1. If present, what I will do, include on first position of C2 in follow position of. Okay, it will be clear for you when we see the example. Okay, so please make a note. I am going to find follow position of I. What I will do, I'll be checking in cat node C1. Okay, in C1 last position of C1, I'll be checking whether I is present. If present, I'll be including all first position of C2 in follow position of I. If not present, I won't bother about that at all. I will move on to the next cat node. Please make a note over here. I have to check all the cat nodes and I have to check all the star nodes here. Okay, so the next comes the star node. So what I will do, I'll be checking if what I will do, if I is present in last position of star node. That's it. Okay, I'm not going for the next node at all. So I'll be checking in the last position of star. Then what I will do, then include all, first position of star in follow position of I. Okay, first position of star in follow position of I. So here please make a note. In star node, I'll be checking whether I is present in last position of star. If present, I will be including all first position of star in follow position of I. Okay, so this is the procedure. So here the follow position will be computing only for the leaf nodes. Leaf nodes in the sense only for the numbered leaf nodes. Okay, only for the numbered leaf nodes. And while finding the follow position, I'll be considering only the cat node and the star node for finding the follow position, right? Okay, we can find the follow position now. Okay, we can have it here. So okay, so what about the positions we are going to find the follow? So position so what I'm going to do, I'm going to find follow position of 1, follow position of 2, for all leaf nodes I'll be finding the follow position, right? Okay, so first we can start with finding the follow position of 1. So what I do, I have to check all the cat nodes and all the star nodes. Okay, so first I am coming across this star node. So what I should do for star node, what I should do, I have to check whether I is present in last position of star. So what is my target now? I am going to find first follow position of 1. Okay, follow position of 1. I am dealing with the star node here. So in star node, I have to check whether 1 is present in last position of star. Is it present or not?
Yes, ma'am.
Yes. So what should I do? I should include all first position of star in follow position of I. So what is first position of star? 1, 2.
2.
Yes. So 1, 2 should be included. Okay, now I can move on to the next one. So cat node here. So here for cat node, what should I do? I have to check whether I is present in last position of C1. So here for this cat node, this is C1 and this is C2. Okay, what should I do? I have to check whether 1 is present in last position of C1. Yes, it is present. So what should I do? If it is present, then include all first position of C2 in follow position of I. So what is C2 here? This is C2. So for
3.
first position of C2 is 3. Yes, good. So 3 should be included here. Okay, next I have to move on to this cat node. So for this cat node, this is C1 and this is C2. What should I do? I have to check the
Just C.
first position, last position of
Last.
C1. Is it present? Is 1 is present here? I'm going to find follow position of 1. Is 1 present here? No. Yes or no? Yes. So what I should do? So I need not consider at all, and then I have to move on to the next cat node. Okay. So now I am moving on to this cat node. For this cat node, this is C1 and this is C2. What should I do? I have to check for the presence of 1 in last position of C1. 1 is not present.
Yes.
So leave it. Move on to the next cat node. Yes, here. So here this is C1 and this is C2. I have to check whether 1 is present in last position of C1. No, not present. Okay, leave it. That's it, right? So I have to, so that's it with the follow position of 1. So follow position of 1 is over. So what should I do next? I have to move on to follow position of 2. So again, I have to check all the cat nodes and the star node. So I'm coming across the star node here. What should I do? I have to check the presence of 2 in last position of star. Is it present?
Yes,
2
ma'am.
present? Yes. So
Yes.
what should I do? I have to include
Put
first
first
position of
position of
star
star
in follow
on
position of
common.
2. Yes, good. 1 and 2. Next comes the cat node.
That
Here what happened? So here this is C1 and this is
last
C2.
here is C1.
Yes, I have to check for the presence of 2 in last position of C1 is present. So I have to include first position of
Position of
C2, which is 3. Yes,
3.
good. 3. Yes, here for this cat node, this is C1, this is C2, 2 not present. Okay. So next move on to the next cat node. This is C1, this is C2, 2 not present. So move on to the next cat node. This is C1, this is C2, 2 not present.
Not
Right?
present.
So that's it. Are you clear with this?
Yes,
Hope you
ma'am.
can try it out for the next 4. Please do try now. Let me have the rules. So I'll be having um, Have you all completed?
Yes, ma'am.
Yes, good. Okay, next we can proceed with follow position of 3. So what is follow position of 3? So first I am going to come across the star node. So here you can see what I should do. I have to check presence of 3 in last position of star. No, it is not present. Okay. Leave the star node. Next move on to this cat node. What should I do? This is C1, this is C2. Presence of 3 in last position. No, not present. Move on to the next cat node. So here this is C1, this is C2. Last position of
Yeah.
C. Yes, it is present. So what should I do? I have to
First
input
position of C.
first position of C2.
C.
So yes, 4 will be included, right? So next move here, 3 not present. So leave
Not
3 not present, right? So follow position of 3 is 4.
4.
Next is follow position of 4. Yes.
4.
So here star node 4 not present in last position. So leave it. Here cat node follow position of C1. 4 is not present. Here again cat node 4 not present. Here cat node, yes, 4 is present in the last
5.
position. What should I do? 5 should be included here. First position of C2 should be included. Next here not present. That's it. Right. And again 5, yes, it is not present in last position of star. Yes, not present in here again for this cat node it is not present in last position of C1, not present, only here it is present. Okay, so what should I do? Include first position of C2, that is 6. And then next comes 6. So here last position of star not present. For this cat node last position of C1 not present. Here again not present, not present, not present. So what is the thing? So it is going to be empty. Yes. Are you clear with this follow position?
Yes, ma'am.
Yes. Any queries? Ma, please don't be hesitant to ask your doubts. Okay. Okay. The next what we are going to do is to construct the, yes, again we will be dealing with the finding the transition table, DFA transition table. So here it is going to be a very simple thing. So here what we will be doing is the start state of your DFA will be the first position of the root node. First position of the root node, right? First position of the root node. What is the first position of root node? 1, 2, 3 is the first position of the root node. So please make a note over here. In this parse tree, this is the root node. Hope you all agree with that, right? So what is the first position of this root node? 1, 2, 3 is the first position. So please make a note. First position of root node is the start state of your DFA. Okay, please make a note. First position of root node will be the start state of your DFA. So here in this case 1, 2, 3 is the first position, first position of the root node. So this is the start position of our DFA. Let me call that as E. So again, as usual, what I have to do is I have to find dtran of all A or based upon all the input symbols. Okay, dtran of A comma A and dtran of A comma B I have to proceed with. So what I should do is, in order to find the dtran of A comma A, please see here. So what are the states present in A? 1, 2, 3. What I am going to give the input as A. So in 1, 2, 3, what are the positions that comes here? So here 1, 2, 3, right? So here in 1 I am having A. So what I am going to deal now? dtran of A comma A I am going to deal with. So what is A? A is nothing but 1, 2, 3. What I will be doing is, in all the positions, which are the positions having this input symbol A. Okay, so please see here, I will be coming across 6 different positions. Each and every 6 different positions will be having different input alphabet. Okay, so here in this set I am having 3 positions. On these 3 positions, which are the positions that have the input symbol A? So here you can see in position 1 I am having input symbol A. Okay, so 1. And next in position 2, I am not having the input symbol A. In position 3, I am having input symbol A. So what I will do is, I will be finding dtran of A comma A by follow position of 1 union follow position of 3. Okay, so follow position of 1, what is follow position of 1? It is nothing but 1 2 3. What is follow position of 3? It is 4. So this is a new set, right? Let me call this set as B. So next what I have to do, I have to proceed with dtran of A comma B. Again, what should I do? I have to check for the positions which is having input symbol B. So A is having 1 2 3. Among these 3 positions, which is mapping to the input symbol B. So here, which is the position mapping to input symbol B?
2.
2. Do you all agree with that? Right? So 1 maps with A, 2 maps with B, and 3 maps with D. So only 2 is having mapped with B, right? So what should I do? So
Follow position of 2.
yes, good. Follow position of 2. What is follow position of 2? It is nothing but 1
1, 2,
2
3.
3, which is
A.
nothing but A. Good. Next, what should I do? dtran of
B comma A.
B. Yes, similarly, you have to construct all the transition, mark all the states. So please do check, do it now. Okay. So please do proceed. You have to find dtran of B comma A and dtran of B comma B. So please make a note over here. Let me give. We have. So what I should do here now? Dtran of B comma A in the sense, I'm having, what is B? So I am having 4 states, 1 2 3 4, right? So among the 4 states, which are the states that maps to A? So 1 and 3
1
maps
and
to A.
3.
Yes, so it's going to be follow position of 1 union follow position of 3.
3.
And dtran of B comma B is nothing but 4 states. Among the 4 states, which are the states mapped to B? 2 and 4. So it is nothing but follow position of 2 union follow position of 4. Okay. So I hope you can deal with that, right? We can continue this in the next class. Are you clear with today's session?
Yes, ma'am.
Yes. Please continue this, ma'am. Let me share these details in the chat box as well. Okay, so that you can continue. Okay, I have downloaded the attendance. If you have any queries, you can please ask, or else you can leave. I'll be sharing these details in the chat box now. Okay, you can try it out and we can continue this in the next class. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Ma'am,
Yes, ma'am.
ma'am, after we had created the pass tree for this conversion, like what was the next immediate step? Like after we,
Repeat. Yes. Can you please repeat?
yes, ma'am. After we created the pass tree for this question,
Ah, ah.
what was the immediate next step that we have to take?
Right. After constructing the parse tree, we'll be dealing with all these 4 functions. Okay. So here, first functionality we have to deal with is the nullable. So first, before that, we have to number all the non-epsilon leaf nodes. Is that clear?
Identify not epsilon.
Huh?
Like how to
Well,
identify?
some of the expressions may have a or epsilon, like that we may have, right? So in that case, the leaf nodes may have epsilon. So all the non-epsilon leaf nodes only should be numbered.
Okay. Thanks a lot.
Thank you, ma'am.